So the question on the screen is course schedule 2. This is built on top of course schedule 1 that I have previously done. So if you have not watched that video, I do recommend watching that video first because I'm going to speed up the explanation in this one. So this is the same, pretty much the same as course schedule 1. It's a classic topological sort problem. You need to order courses. So every prerequisite comes before the course that requires it, returning an empty array if a cycle makes that impossible. So we are going to use the same Kahn's algorithm, which is BFS, which will handle both these paths. In course schedule 1, we just had to return true or false, whereas in this one, we have to return the order of the courses. So the way it works is that we start in the same way. We start by building an adjacency list from prerequisite to dependent course, and then we track each course's in degree, which means how many prerequisite it still needs. Repeatedly take a course with in degree 0, which means nothing blocking it, add it to the order, and then unblock its dependents by decrementing their in degrees. By dependents, I mean neighbor. If a cycle exists, those courses never reach in degree 0, so the final order comes up short, and then you just return an empty array. So we build a graph. Now this will create an empty list per course, and it will hold, every course will hold its prerequisite. Then we have in degree. So this creates a counter for each course tracking how many prerequisites it has still unmet. Then this is unpacking prerequisites. So each pair in prerequisite is course and pair, meaning to take this course, you must first take a prerequisite. Therefore, we are recording an edge in the direction from prerequisite to our course, and this is how we are appending it. And then each pair also means that the course has one more prerequisite blocking it, so we increase it by 1. Now we are building a queue data structure. In the previous question, course schedule 1, I did a for loop, but this is like a one-liner. So what this is saying is that it's scanning all courses and puts every one with zero unmet prerequisites in a queue. So these are like the valid start points. You can do it the same way I did in course schedule 2. This is just much cleaner and something new to learn. And then we have order. So this will collect the final course ordering as we proceed further. We're going to start by going forward with a while loop until our queue is empty. So as long as there is at least one course that we can take right now, we take one of the front of the queue, which is pop left, and then we commit it to our schedule, which is order dot whatever we popped, we append it to our order. Then we explore its neighbor. So for neighbor in graph of this particular node that we popped, now because we have completed the course, we look at every course it unlocks, and then we decrement its counter. Now if this neighbor courses counter has hit 0, which means all its prerequisites are done, so it joins the queue of the takeable courses. And then we append it. Now this is the cycle check. So if the prerequisites form a cycle, so for example A needs B and B needs A, these courses never reach in degree 0, so they never enter the queue and never land in this order. So order comes up short and we return an empty array as the problem requires us to return. Otherwise, order contains all courses in a valid sequence.